Hello everyone, and welcome to the first video about essential information regarding scripting in Unity. This series is going to be pretty basic. It's not going to cover like crazy advanced topics, but it will go a little bit more in depth on certain elements of scripting that are commonly used than you might normally get from a tutorial. It's not going to teach you how to script as much as teach you some of the terminology and also help you get a better understanding of the things you are using while scripting. So let's go ahead and get started. Today we are talking mostly about data types. We're going to start with value types, which you might not know what that is, but essentially it's like integers, floats, stuff like that. Maybe we'll get to reference types today, which is like strings and classes that you build yourself. But we'll see how far we get. I'm going to start off with integral types or integers. There's a lot of different types of these. They use a different amount of memory based on how much they can hold. So for example, an int, which is commonly used, can hold 32 bits of data or 4 bytes. And that means the largest and lowest number that it can hold as a signed integer is negative 2,147,483,648 as the minimum, and the maximum is 2,147,483,647. And I could go into detail about why the maximum the absolute value of the maximum is 1 less than the absolute value of the minimum. But that's, kind of outside of the scope of this video. So just know that it has to do with a method of creating signed numbers, or a number system that can go negative and positive on a computer. That's called 2's complement. So if you want to look that up on your own, I'd encourage it because it kind of helps you understand why it stores that way. But something important to know about integers is if it reaches the maximum and then you try to increment beyond that, it will loop around and do what's called the integer overflow all the way back to the negative, the most negative value. It also depends on the programming language you're using and how they handle integer overflows, but that's a common way for it to react. You won't really need to worry about that because it's such a large value. It's unlikely you'd be in need of an even larger value. The other kind of integer that is a long, which is 64 bits or 8 bytes of data. I'm not going to even read out that number, but it's right there. And so that's, integers. Pretty simple, pretty straightforward. What I mainly want to talk about is floating point types. With floating point types, for example, with a float, you have 32 bits or 4 bytes to represent a number to a certain level of precision. So with the number of bits available to a float, it can have a precision of around 6 to 9 digits. That people generally say around 7 is how accurate it can be. And essentially what that means is if you need a really precise location, let's see, between 2 points, and you're looking at like 0 and 1, then you can get pretty precise because you have up to 7 digits or 7 significant digits to work with. So it could be like 0 point, 1, 2, 3, 4, 5, 6, or whatever. However, if you start to get into larger numbers, so if you get to like, let's say 100,000, then stuff starts to get weird because it has a harder time calculating because it only has so many digits to work with. And if you have 100,000 trying to go to 100,001, already 6 significant digits are being taken up. And so you only have 1 digit to work with for precision, roughly 1 digit to work with. Obviously, there's a little bit of leeway there depending on what the number is. So I can represent that right now, actually. So I have a scene open. It's a default scene for the URP template, as you can see. And what I grabbed it for is so that I could have some stuff to mess with. to show what I'm talking about. So you see this paintbrush, it's, pretty simple paintbrush, cool. So we're here near the origin, it moves around, everything looks pretty normal, you're just moving a paintbrush. So let's try something different. So let's set this to 100,000, like I mentioned before. And now if we focus it, something weird happened with the paintbrush and also with the controls in the viewport. That's because Unity, for its coordinate system, well, actually for basically any values that need precision past the decimal point, uses floats because, floats are able to be used reliably on most systems. A lot of systems, especially graphics cards, still don't work well with data that uses more than 32 bits. There's also something called a double, which uses 64 bits, but it takes longer to process that data. And so it's just more efficient to use floats and more friendly to a wider range of devices. And so as you can see here, the brush is all weird. And if you move it, it gets even weirder. Why this is happening is because each vertex needs to be calculated. And the problem is with the location of the brush, it doesn't have a lot of space left to make those calculations. It's using most of that space just for its base location, which is at z equals 100,000. And so this is what a floating point error looks like visually. It's where it's trying to get it as close as it can to what it should be, but it only has so much space to work with. And so this is the closest approximation. It is for these vertices is this weird janky thing. And as I'm moving it, it's recalculating and based on its new position. And so that's why it's doing this weird wobble. What's important about this in particular, about understanding floating point errors, is that as the number gets larger and larger and larger, things are less and less precise. And that can lead to weird graphical bugs, it can lead to weird physics bugs, it can lead to all kinds of weird stuff. Basically, anywhere you're using floats, once it gets to a certain size, stuff can get weird. It has caused problems in the scientific and military community previously where, the floating point errors slowly added up over time because it was a system that was, running on a time sequence and it was using floats to measure certain things. And even when you are in your origin, there are going to be some minor errors. And the further you get, they get larger and larger. So that's something that's often important to account for, especially with time-based calculations that are ongoing throughout the game or any program. A good example of ways to avoid this, or of situations in which it might arise, is common one would be a endless runner. Another common one would be like a space exploration based game like Space Engineers or No Man's Sky. Something like this would crop up as an issue, having to deal with floating point errors or avoiding floating point errors. And I'm sure there's plenty of other examples, but those are the ones that come to mind quickest for me. And how you'd avoid it is, instead of moving the player in world space, you move the world around the player and try to keep the player as close to origin as possible. Obviously, it might not be completely possible to always keep the player exactly at the origin depending on the game, but just keeping them close to origin is really important to help avoid these types of errors, especially in Unity or any engine that uses floats, which is probably a lot of them since it's a more efficient form of storage, even if it's less accurate. So that's my thing about floats. Lastly, there's two additional data types to talk about. There are Booleans, which are very simple. It's just true or false. A Boolean is literally just, it's basically just one bit, because it's either a 1 or a 0. And then there are chars, which are just individual characters like you would see in a string. The reason we're not talking about strings with value types is because a string is actually a reference type. It's a collection of characters. So it acts differently. So that's a rundown on integers and floating point types. Not anything too complex, probably not anything too exciting either, but hopefully it helps you, at least especially with the floating point numbers, understand it a little bit better.